For those people who are interested, red dwarf stars are stars in intermediate stages of stellar evolution. They're not figments of the imagination, as are dark matter, dark energy, black holes, and all that other pseudoscience. They are real objects. They are actual stars that shine from their own light, and they are much smaller than the sun. Red dwarfs are what we can call M-type stars. They're much more evolved than G's and than A's. The brighter you get, for the most part, is equal to youth. So if we have a really bright A-type star, it will cool and shrink and become a G-type star, which will cool and shrink and lose mass to solar wind, which is chemical heterolysis, in other words, electrolysis, and will continue to flare and cool and become what's called a red dwarf. And a lot of the red dwarfs that we have are actually flare stars, meaning they lose so much matter that they shrink. They start shrinking considerably and cooling once they get to this stage. We have all ranges of red dwarf evolution, starting with the brightest. This comes right after orange dwarf. The Epsilon Eridani video covers that. But once it reaches this temperature, it starts cooling and cooling and cooling, and its luminosity decreases significantly. And this is as opposed to the luminosity of the sun. That's what that little circle means right there. Solar radius, solar mass, and luminosity. So as the mass decreases from mass loss, so does the radius, so does the luminosity, and so does the temperature, and this is in Kelvin. That's the surface temperature. Notice how when you get to M1V, that's half the diameter of the sun. When you get to M5V, the luminosity is 0.22, so 1/5% the brightness of the sun. And then you have 1/5 the radius of the sun. Go all the way down to where you have about a little less than 1/10 the radius, and basically 1/100% the luminosity of the sun. So these things are going to be very, very dim, and these are very evolved stars. After this stage of stellar evolution, we have what are called brown dwarf stages of stellar evolution, to when most of the material is moved out of its plasmatic stages and is condensing and forming, or beginning the formation of a core in the center of the star. But more on that later. Here are some spectral standard stars. I see the academics have gotten really busy with labeling everything, but that's about all they're really good for, is labeling things. The M-dwarf primary spectral standards are GJ250 is MOV, GJ229 alpha is M1V, all the way down the line. Remember, the M9V is the coolest, smallest, less luminous, and less massive stage of the red dwarf series of evolution. This is very important to look at the red dwarfs, because these stars are the beginning of what we would like to call, or what I would like to call, the end of stellar evolution as according to establishment dogma. To them, red dwarfs are basically the last stages of a star. And then once you get past red dwarf, you get into brown dwarfs, and currently establishment dogma is confused. They think brown dwarfs are substellar objects, or they're failed stars. But the truth is that they're just evolved red dwarfs, which are in turn evolved orange dwarfs, which are in turn evolved sun-like stars, which are in turn, you get the point. The stages of stellar evolution are lengthy and require deep time. I've already talked to Charles about that. He already understands what's going on here. And here we are, a very familiar graph with a lot of my viewers. The red dwarfs are M stages of stellar evolution. They sit right here. Proxima Centauri sits right here, and Wolf 359 sits right here. This is the stage of stellar evolution when scientists lose their minds, and then they all of a sudden go, oh well, since we can't see it, it must not be going. Thermonuclear reactions, thus ceasing the ability to shine. Well, they're clueless, because stars are not powered by thermonuclear reactions. They're shining because of plasma recombination. The birthing event is what all the star collected all of its energy from. Over its lifetime, after it's born, it cools and shrinks and combines the elements into molecules, forming what are called planets. But anyways, the red dwarf is right here, and the next video I'll make will cover brown stars. And brown stars are failed stars to establishment. They don't understand that they're actually just evolved red dwarfs. I don't know why that escapes them. It's pretty obvious to me where they fit. But and then we go into gaseous stages of matter, because the matter is not radiating anymore. It's not plasmatic anymore. It's gaseous. And the majority of the heat begins to internalize in this stage. Thus, instead of having a hot surface, the heat moves inward, and the star remains hot as it gravitationally collapses. Hopefully people can get the word out on this. It's pretty basic to understand. Okay. Oh yeah, today is January 19th, 2015. It is 6:53 p.m.